Good morning. So am I audible? One of you just raise your hand. Yes, thank you, Navin. Yes, I'm audible. So let people join slowly. So we are supposed to talk about lab. I hope all of you were there in Canvas. In the Canvas discussions, I have posted two YouTube links so that you can you can see the demonstration of first experiment there as two videos. I hope most of you have seen. So we'll go slow, let people join. So we'll try to go with experiment number 2. So 12 participants. So I will try to share the list of experiments. Hope you can see. The first experiment is about investigation of launch pad details. Hope you have seen the difference, enough difference about G2553, F5529. And the part B in experiment number 1 is about Code Composer Studio version 6.1 and Energia. So we have seen in the last lab about Code Composer Studio, and the usage of Energia is also posted in the canvas. Now, flash onboard LEDs. We have two LEDs, red LED and green LED, which we have seen working with them in Code Composer Studio in the last lab. So let's go with experiment number 2. We want to talk about experiment number 2 for this 40 minutes. So experiment number 2 is flash LED, control LED using software delay by reading input from a switch. We can plan different ways of doing this. One way I'll try to talk. The rest of the ways you can plan. Let's do like this. We'll do one thing. We will switch on red LED, and the minute when we press the push button, we want red LED to switch off and we want green LED to switch on. Okay, so we can also make this routine topsy-turvy or whatever you want. We can do. We can press the switch. The minute the switch is on, we can turn both the LEDs on, or we can demonstrate the output of a NOT gate. Take red LED. When the switch is off, you see red LED. When the switch is on, switch LED should be off. Okay, whatever it may be, we want to control LED with a switch. So let's go with. I'll stop sharing this. I'll share the presentation what we are watching. I'll pick from there. Okay. So all of us were well convinced in unit 2 that all the peripherals are handled the way how you handle a memory location. I mean to say, when you say an LED or a push button switch, which is connected to a parallel port. When we say parallel port, a parallel port is defined by programming all these special function registers. We have visualized them. Direction. So when I set, it's going to make the particular pin as output. And similarly, when I reset, it's going to change the direction as input. Okay, similarly, when we talk about out, now out is the SFR which is having dual functionals. The function when a port is output is what you want to send it, and when a port is input, we try to do pull up or pull down in PX out. So when we talk about the functionality, when the direction is output is, when you write 1, LED will on. When you write 0, LED will be off. The dual functionality, when you write 1 here, it's going to pull up. It's going to pull up. And when you write 0 here, it's going to pull down. So when you want to pull up or pull down, when a particular port is input, is you need to choose the resistor. All right. So resistors is available here. Resistor is available here. So when we want to talk about switch in this experiment, when we want to talk about a switch, a push button switch in this experiment, you have to read from the switch, am I right? So MSP has to read from the switch. So this should be an input pin. Similarly, when you want to control an LED, the pin at which LED is there should be an output pin, am I right? So the pin at which switch is there should be an input pin, and the pin at which LED is there is an output pin. So this is chosen by direction. So when you connect a switch, say you are applying the switch with VCC. One switch, push button switch will have 2 plates. If you drive one of the plates with VCC, if you push this switch, when you push this push button switch, this VCC is available here. Agreed, right? This VCC is available here. There is a confusion. What is available at this input pin if the switch is off? So we should add a resistor, and this resistance is enabled at the input pin for not okay, I can see who is annotating on my screen. So this resistor is enabled by making 1 for enabling, 0 for disabling. Now the alternative functionality of this out will choose whether we pull it up to VCC or we pull it up to ground. Say if I pull it down, let us understand when I pull it down. So all of us know LED is available at P 1.0 and 1.6. We can work with red LED 1.0, green LED 1.6. So we will try to investigate now at what point this launchpad switch is connected to. So So let me break the ice. It is available at 1.3. One push button at 1.1 and another at 1.3. So now when the switch is off, when you pull your hand back, what P1.3 reads is 0 because of this ground. And when the switch is on, P1.3 becomes logic 1. And this transition you see only when the switch is on. So whatever we want to do when switch is off, we will do. When the switch is on, whatever you want to change the story, we will change it in the program. Now, hope everything is clean. I can talk about another combination. If you drive one end of your switch plate with ground, if you want to make it to ground, the intelligence is you have to pull it up. Am I right? Now you have to pull this resistor to VCC. So when the switch is off, you will read VCC. When the switch is on, this VCC is found to ground. That's it, because of this resistor. Am I right? So these are the alternative ways. And the question now to make it clear here is the switch status will be available in this register called in register. So we have understood talking about direction, dual functionality of out, input, and resistor. So we will talk about rest of the SFRs in our third experiment. So hope we have already been talking about it. Just to make a quick review, we had this slide, and I will try to move to the current experiment, or I will try to take you to another share. I'll try to show you another document. Okay, so please be with me. So this document, hope it is clean. You can see it. I will go to, so this is our experiment. We want to control an LED with a switch. Okay. So let us watch these details then. This is the launchpad details. Okay. This is MSP430 G2553 we are talking about. So this slide is telling me details that switch is available at 1.3. All of you, please make a small note. So we have red LED at 1.0, green LED at 1.6, and push button switch S2. There are in fact two push buttons. Switch 1 to reset the launchpad, hardware reset, POR, power on reset, because we have just discussed about it. And we have another switch at 1.3. So all of you scribble it down in your books. We have switch at 1.3. Now we will try to move forward. Okay. So this document is trying to switch the LED on when the switch is on. And when the switch is off, you are going to turn the green LED. So green LED is showing the status of switch 2. Okay. So I will take you to next slide where we have a in detail discussion of this. Okay, so any microcontroller unit, if you want to make port as an input port, you have to talk about the direction. After direction as input, you have to enable the resistor. And if you decide to connect one end of the plate to ground, you have to pull this resistor up. So we have seen both the explanations now. So when you pull up, one end of the plate should be grounded. So it is very clean in this figure. When you are pulling up, when the switch is on, so you have switch at P 1.3 according to our discussion. So when I have a switch, when the switch is off, when the switch is on. So when the switch is off, your 1.3, in this situation, your 1.3 will be at VCC or logic 1 when the switch is off, and when the switch is closed, when the switch is on, when you push this switch, push button switch, when you push it, it's ground or logic 0. And this is available in P1.3 now. Okay, the alternate discussion, we did it. We can either pull up or pull down. But when you look at the document, it has to be pulled up. Why we say it has to be pulled up is one end of the switch is already grounded on the launch pad. So hope the story is clean. I will take you to next slide next page where we have launch pad details. Of course, it's not clean here. I'll stop this. I will take you to another document where we have it in detail. Okay, yeah, please. So launchpad is clear here, I feel. So if there is any issue, just raise your hand. Okay, we will stop and we'll go. So we have red LED at 1.0. This is LED 1. Okay, we have green LED at P1.6. So this is green LED. This is green LED. So we have a couple of push button switches. All of you can see reset. Is this push button is reset, and we have this push button 1.3 because it is tied to reset. This is reset button, hardware reset button, or POR. This causes POR. Let's not use this. This is where a reset button is there. Switch 1 is connected there. Now we want to work with P1.3. So we got LED, we got switch at 1.3 LEDs now. Hope it is clean. Okay, I will stop this screen. I will try to take you to another. Okay, so there we go. We have flow chart. All of you can look at it. The first thing what all of us need to do is disable watchdog timer. So in this, green LED is being used to reflect the status of switch, but our experiment is different. I told you, switch on red LED when switch is off, switch on green LED when switch is on. This is what we want to try to write. So maybe I'll ask you back, one of you respond back with that program. So it was demonstrated that launchpad contains switch at P1.3, and the one plate of the switch is connected to ground. So we have no option except pulling it up. We have to enable the resistor and we have to pull it up. So whatever I have shown in the earlier page of this document is true for this. I mean to say, this is how the switch was, one of the switch is done with. So when you try to hang a connector outside your breadboard and you want to decide your button, you can also pull it up. You can also pull it down, tying other plate of the button to VCC. Okay, this is a valid setting which we could do. Hope you can understand. So you can ask me to explain in detail if you can't get it. Okay, hope you're super comfortable at that end. I will go with the flowchart then. Then all of you can watch this part. This is a cakewalk. When we have to check the status of the button. So when the button is pressed, I mean to say, you have to look at P1.3. I mean to say, you have to look at port 1 input register. You have to look at port 1 input register, because input register is where you see status of the push button, and you have to specifically talk about point 3, P1 in point 3, because this is where we have the switch. Now, if you read this 1, if you read this as 1, your switch is off. Am I right? So your switch is off or on? It is on. Am I right? When you read it as 1, because you are pulling up. When you pull up, when the switch is on, it will read as 1. Okay. Do you have any discussion here for me? So one of you, if you have any doubts with me, or if you say I'm going wrong, you can stop me and correct me. Because I just want to know what are you doing at the other end. So is it correct? Or you say I'm wrong? Vardhan.
Switch 0 means LED should be on.
This is what I know I'm doing wrong, but other than Vardhan, what's happening there at the other end? So anybody can unmute yourself and you can talk. No questions from anybody else? Okay, so as Vardhan was trying to correct me, I was wrong. Okay, when you read P1 in point 3 as 1, so when you are reading it as 1, you are reading this VCC, am I right? You are reading this VCC. So the switch is off. You will read this VCC when switch is off, am I right? So my discussion was wrong. So when switch is on, what you read is 0, because this VCC is forced to ground. Okay, now hope we are clean here. Okay. So I will take you to the same slide. Okay, we need to check the button. So now here I want to bring in a concept. When you are watching for a button is an event. Am I right? Event can be polled. So always when you look at the program looks very easy every time. But any event can be either polled or tied to an interrupter. Am I right? So I want one of you to come out. Events can be polled or events can be recognized, especially on an input port. When we talk about input port, we don't have control over input port. Am I right? We have control over output port. So when events are arriving, they arrive on an input port. When you are trying to poll, you can either poll or you can either recognize by an interrupter. I want you to come out because experiment 3 is about interrupts. Now I have only one question right at the minute to make the thing simple. What is which is advantageous way of reading events, polling or interrupts? So Vardhan.
Polling is prioritizing, sir.
Polling is?
Prioritize. Priority of the events.
Okay, so I mean to say, we have experiment number 3 with interrupts, okay? I think experiment using interrupts is advantageous, am I right?
Yes, sir.
So polling, why do you think is disadvantageous? So I was trying to talk about experiments 2 and 3 together here. So polling is something like when I'm having my class, my eyes should always be on the door, because I don't know who will be coming. Am I right? Each and every time I keep looking at my door, I will always get deviated from my concept. So polling is always deviating. So instead, what I could do, I could close my door. I could close my door. If somebody comes, what they will do, they will knock the door. I don't need to watch the door always. So knocking is interrupts. So interrupts is always advantageous because I don't need to keep my eyes on the door. Am I right? When an interrupt comes, there will be a flag. So let us try to poll this switch in experiment number 2 and using interrupts in experiment number 3. Okay, that's the agenda. So we will try to go with polling first. So all of you can watch the program. It is right there. So I have to stop the watchdog timer first. And all of us have answers now. When you don't stop the watchdog timer, what is generated? POR or PUC? We have just discussed in the morning class. POR is power on reset. PUC is power up clear. So what do you see? POR or PUC? So you will see PUC because it is software. Okay. Now hope we will go. Now if you look at direction, so how many directions are essential for you now? You have LED at 1.0 and switch at 1.3. LED should be out, switch should be input. Now if you write the hexadecimal equivalent at P1 DIR, right from 1.7 to 1.0, your combination will be 40. Am I right? So you have to write the direction of LED as output and switch as input. I think all of you can guess there is a error here. Okay, so I have to write it as port 1 direction. So which LEDs we wish to use? For example, if I want to use green LED, what should I do? I have to set the direction where I have green LED. I have green LED as at bit 6. So what's the direction? Direction, if it is 1, it is going to be output. Am I right? So I want to use green LED. So how to set it? By logically R-ing with 1. So this will turn the direction of green LED as output. Okay, if you wish to use red LED too, you can put a plus bit 0 here. You can put bit 0 here. Okay. So don't stick with this program because I always have mistakes in the program, because only when you have mistakes you can correct it. So run. Let's talk about port 1 resistor enabler. When you have to enable, you have to write 1. So you have to logically R. So you have to logically R, where you have to put 1, where you have to enable the resistor at the, you have to enable the resistor at
P1.3.
You have to enable the resistor P1.3, because P1.3 is where you have to enable the resistor. Am I right? So 1.3, all of you know, I will share presentation. Okay, because most of you, I see you are struggling there. Okay, your switch is at 1.3. So what should you do at 1.3? You have to enable the resistor. So putting 1 is either this or writing bit 3. Okay, hope you are comfortable now. I will take you So I was trying to switch lot of shares from my end. So I'll go here. So there I have 8 here. So then if you look at the main loop, we have a while one loop. So just watch this while one loop. The way how you are polling is, if P1 in, I told you P1 in is where you have to go, and you are interested in only watching bit 3. So you can also write the alternative line like this. If P1 in dot bit 3 is double equal to, so you have switch at bit 3, right? Bit 3 is double equal to 0. You can write an if statement like this. There are, because this is program, I have lot of alternative ways to do. If P1 in point bit 3 is double equal to 0, when you read it as 0, when switch is on, okay? So then you can glow the green LED like this. If this if condition is not met, it is true else. So you will come here. In else, you are switching off the green LED. Okay. I hope the idea is clean. Hope you understood the program. So what we did here is, I am trying to go through once again. You have to check the direction. You have to enable the resistor. You have to pull it up. So pulling up, you have to do it in P1 out for an input port, the alternative functionality. In a while one loop, we have just said polled the switch. The switch is on, we are trying to glow green LED, else green LED is off. So now I will stop sharing. We were done with the second experiment. I know it is very simple, but to make the discussion meaningful, I want all of you to write a program now. So program, what is our second experiment? Turn the red LED first. And I want my push button at 1.3 to be the status indicator for the push button. So hope you got me. What I want to do is, so all of you can see my whiteboard. So I have P1.0 in the story. So you should write program now. All of you should write program now. P1.0, P1.6 and P1.3. I am working with these 3 pins now. So P1.3 is a switch which has to be pulled up. You don't have any other option because that push button is already soldered. The plate of the push button is tied to ground. Now, when the switch P1.3 is, when you read P1.3, you have to read it as P1 in point bit 3. When it is 0, switch is on. We want to say switch is on because it is pulled up. When the switch is when switch is reading 1, when will you read 1? Sorry. So this is off, am I right? This is off. When you read switch as ground, okay, correct me. I want one of you to correct me out. Okay. So I'll try to make inputs on this side, P1.3. So P1.3 is readable by using P1 in. If you got me very cleanly, you can start writing your program. I was trying to work for those dummies who cannot write a program. So P1 in point, for example, bit 3, this is how I check, right? So if P1 in point bit 3 is double equal to 0 or double equal to 1. I have two options. I can put if here, else here, or if here, else here, whatever I want to do. I want you to just decode me. What I want to do is, on the left hand side, I have inputs. On the right hand side, what I have is outputs now. So outputs, what we have decided is to use two LEDs, green LED, red LED. So it is 1.0 and 1.6. I told you 1.6 should hold the status of the switch. So when P1 in point bit 3 is equal to 0, switch is on because it is pulled up, am I right? By default, it is pulled up. So I want this red LED to be off because this on should be reflected here. I want it 1 here. So when P1 in point bit 3 is double equal to 1, pulled up, so the switch is off. When I am receiving that pull up, the switch is off. When switch is off, I want green LED to be my status, switch off, but red LED should be 1. Okay, so this is what I am planning. Initially, when the switch is off, I want red LED telling me that no, red LED is telling me that no switch is on. The minute when you switch on the LED, you want green LED to glow. And the minute you remove hand from your push button, it goes back to off and you want red LED. Okay, done. You can start writing program. One of you can share this program to me. I can make you co-host if you want. Start going then. One of you can turn your camera, show me your notebook. One of you can turn, I'll make you co-host. You can put program on your whiteboard. Okay, 3 more minutes is left for us. So we were done with experiment number 2. Okay. So one of you can unmute yourself and start talking now. We were done with experiment number 2. Vardhan, are you there?
Yes, sir.
So have you written the program?
Writing.
Yeah. Please complete it. And I'll make you host, okay? You can show your notebook, okay?
For toggling of the switches, no, sir.
Yeah.
For toggling of the switches, LEDs, no, sir.
Yes. Second experiment, polling. I want you to show polling. So 3 more minutes, okay? So if you have any questions, we can do. Some others can unmute and we can have a discussion. Any questions? So then don't get confused. We are trying to write Mbed C programming. Okay, we are trying to do assembly programming in the classroom. So maybe so this is what I'm asking you to do now. So you can check this because time is running. I wish to show. So one of you can analyze this program and tell me what is happening. This is third exercise. Because I know we are working with P1 and P4 here. So this is about F5529. When we talk about F5529, switch is there at 4 point. Switch is there at P1.1, but switch is there at 1.1 and green LED is there at 4 point something. P4.7. Yeah, P4.7, yes. So like this, if you start working out different programs, then only you can write a program. So you don't need to copy somebody else's program. Okay, copying does not works out always. There is an alternative I am trying to show, because the whole class, so only Vardhan is responding to me. Yeah, you can see this combination. You can tell me what is happening. You have a software delay here, while loop. So you can pour out all your C skills here. And it is 12:41. Vardhan, can we close, or you want to show your program?
No, sir, it will take time, sir.
Okay. Not an issue. Okay. So this is how the lab cycle goes. We will try to demonstrate it in the next class. If you give me a program, okay, I will run it if you give me a program. Okay. So thank you for joining.